turns out the environment has a major impact on biology. And for the past 50 or 60 years, a large number of observations have been made to suggest that genetics really can't explain many of the things we're seeing. The first is there's regional disease frequencies. Go anywhere in the world, the frequencies of different diseases is different. If you take someone early in life before the age of about 5, move them to a new region, allow them to grow up, they will develop the disease frequency where they grew up. So this can't really be a genetic phenomenon. It has to be more of an environmental phenomenon. We've looked at a large number of the major diseases we have, and we've looked for genetic mutations that correlate to those diseases. And in many cases, we have found genetic mutations, but pretty much across the board, it's in less than 1% of the population with the disease. Less than 1%. So it's good that we found some genetic mutations, but what about the other 99%? If you look at pretty much any of the major diseases, the increase over the past 20 or 30 years is so dramatic. In many of them, it's a 10-fold increase. For autism, it was 15 years, 10-fold increase. I'm sorry, there's no genetic mechanism known that could explain that phenomena. It has to be induced by the environment. So epigenetics are these small molecular factors around the DNA that regulates how the DNA functions, what genes are on and off. But it does this completely independent of DNA sequence. And so it's these molecular factors around DNA that regulate how it works, what genes are on and off, but it's independent of DNA sequence. And when a cell divides into 2 daughter cells, not only does it replicate its DNA, but it also replicates its epigenetics so that it keeps that maintains that cell identity. It's a pretty doom and gloom situation. What your ancestors were exposed to is going to affect your disease, and what we're exposed to, likely a different set of contaminants, we're going to pass on to our grandkids as well. Okay? However, so I'm going to give you the upside. So essentially, knowing this phenomena exists, knowing that there's epimutations in your genome that may be exposure specific and directly correlated with disease, we can now use these as diagnostics for those past exposures and potentially what disease you're going to get later in life. So early in life, in your 20s, we could potentially analyze your epigenome, determine what your ancestors or you were exposed to early in life. Because of that, what diseases you have a high susceptibility to get later in life. This allows us then to put into the whole thing called preventative medicine. We can do preventative therapeutics, preventative lifestyle changes, and so forth to actually prevent the disease from ever developing. The reason we haven't done that yet is we never had early stage diagnostics. Genetics has not provided that to us today. Epigenetics gives us that capability. So we may not be able to fix it, but we definitely can treat it, and this would have a significant impact on future medicine and health of the population.